the celestial objects, that is the stars, etc., you can see in the sky. Now, related to the description of motion of different objects in physics, there are different branches where we will describe the motion of the different objects, namely they are kinematics, dynamics and statics. So, in kinematics, we will discuss the motion of the objects without reference to their cause of motion, whereas in the dynamics, we will discuss the motion of the objects with reference to their cause of motion. And there is another branch of physics where we will deal with equilibrium conditions of the objects. That branch is statics. So, like that, in various branches we are going to discuss the motion of the different objects depending on their situation of motion and the cause of their motion. In kinematics, we will deal with the objects mostly which they are moving in a straight line path. So, when the particle is moving in a straight line path, that is also considered as it is in rectilinear motion. Introduction to the rectilinear motion. Let us imagine a person is under training to shoot the bullets. So, what is his aim? He will give a target and a bullet is fired to hit the target. So, in that context, the bullet is going in the form of a straight line. So, whatever the object which moves in straight line, we can consider that is in the rectilinear motion. In this case, of course, we are neglecting the gravitational pull experienced by the bullet. We are neglecting, because when compared to the deviation given by the gravity, since the bullet is fired with high kinetic energy, the effect of that kinetic energy is more. So, the gravity effect is negligible in that case. The number of turns in the given coil is 20, whose radius is 10 centimeter, which is in the circular form. Convert centimeter into meter, then area is pi r square, and it carries a current of 5 amperes. It is placed in a magnetic field of 0.1 Tesla, such that the normal to the plane of the coil is in the direction of magnetic field. When the normal to the plane of the coil is in the direction of the magnetic field, the angle between the direction of magnetic field and normal to the plane of the coil is nothing but 0 degrees. And you know that torque tau is equal to B N A sin theta, and here you substitute all this data and this angle theta is 0 degrees. As this angle theta is 0 degrees, you know that sin 0 is 0, 0 into something, this whole term vanishes. So, in this position, the torque acting in the coil is 0. At the same time, the net force on each arm. So, on one arm, if the force is acting like this, in the other arm the force is acting in opposite direction. So, these two are equal and opposite forces acting on the same line. Thus, the net force is also equal to 0. Now, the wire's area of cross section is given as 10 raised to minus 5 square meter, and whose number density, free electron number density is given as 10 raised to 29 per cubic meter. Then the force experienced by each electron, F is equal to QVB, and here Q is nothing but the charged particle electron, and since it is current is flowing through that, each electron is moving with a constant speed that's called drift speed, and it is placed in uniform magnetic field of induction B. And further you can write drift speed is I by NEA. So, EE gets cancelled, so that B into I by NA. So, B value is given as 0.1 Tesla, current is 5 amperes, and number density is 10 raised to 29 and area is 10 raised to minus 5. On simplifying this, you are going to get 5 into 10 raised to minus 25 Newton.